All right, so welcome back, guys. In this video here, we're gonna discuss the concept of limits and just briefly introduce the formal and informal way of looking at limits. And limits can be very important for us. Where it is the most important concept throughout calculus series, and everything we do in this class will relate back to limits. We need this concept limits to be introduced before we can start discussing some of the application that we're gonna go over in this class. Business calculus for economics. Um, so let's start with it. Okay, suppose we have a function. Okay, let's look at an example. Suppose we have a function or an equation. Suppose we have functions f of x equal to maybe x plus 2, right? So this is the line. If you remember, this equation will define on all the real numbers, or that'll be your domain, and the range would be the same thing, right? And if we're gonna graph this here, it's just gonna be a line, start at 2, and then the slope's gonna be up 1 over 1, so we're looking at a graph like that, right? Okay, so now, okay, I wanna look at the same graph, the same equation, x plus 2, but I wanna exclude x equal to 1 from the domain. Okay, so this is notation. We're saying that this function defines on every single value of x except for x equal to 1. Okay, now let's look at the graph of this now. Okay, so let's draw the graph. All right, so it's going to start at 2. Okay, and it's going to be slope is up 1 over 1. So we're looking at right there. So maybe your graph will look like this. Okay, so that's going to be a line. All right, arrows. Okay, so what does it mean to have this function be defined undefined at x equal to 1? It means that when x equal to 1 here, there is no y value happening there. So to indicate that visually, we're gonna go ahead and I'm gonna go ahead and just erase this part here. Oh, I don't want to do that. So erase just partially. So maybe just right there, and then just show that by drawing a circle around that. So this means this graph here is undefined when x equal to 1. All right, so this doesn't have a y value equal 1. Okay, so what does it mean for just to say the limit of this is approaching 1 and such and such? Now I want us to do this. I want to look at just some x values that are really close to 1. Okay, so let's consider x on the right side of 1. So we're gonna go ahead and look at value of x that approaching 1, not equal to 1, but just approaching 1, getting really close to 1 from both sides. Okay, so let's say x is equal to maybe 1.1, for example, and then let's say 1.11, 1.111. So a little bit closer, right? So if x equal to 1.1, then y is going to be 1.1 plus 2. So it's going to be 3.1. Here is going to be 3.11, 3.111. Now let's look at value of x to the left of 1 that is getting closer to 1. So maybe 0 0.9, 0 0.99, 0 0.999. The y value correspond to that is going to be 2.9, 2.99, 2.999. So what's happening here? What's happening here as x get pretty close to 1 from both directions, the y values are getting closer to what? To 3. Okay, so the way we describe that mathematically, we say that the limit, right? So lim is short for limit, as x approaches 1 of the function, okay, is equal to 3, right? So this means, right, so this notation, right, if I have to spell out in word here, it means that the function values is approaching 3 as x approaches as x values as x values get close to 1. Okay. All right. So notice that we're not observing what happened at 1, but we're observing as x get closer to 1, the y values or the function values, the y values or the graph is getting closer to 3. Okay, so we call that concept is limit. So formally we define as the following. Okay. So formally we're saying that so definitions. Okay, we're saying that the limit of f of x as x approaches some number c is equal to L. Okay, or as x approaches c, f of x approaches L. Okay, L is just some finite number, right? So we're saying that, right? So this means as so the function value is approaching a finite number L as x get closer to c but not equal to c. Okay, so that's the limit. Okay, so why is this important? We're soon to find out where we're going to use this in a lot of application that we're going to discuss in this class. So it's just a concept of when the domain, the inputs are getting close to a particular value, we're observing on the graph visually on the graph visually. Let me just go ahead and do that. On the graph visually, what's going on there? The y values are getting closer to 3. Okay, so here's a theorem that will probably will make things a little more clear, or all at the same time make it more complicated. So it turns out that we have scenario where the limit may not exist because we have discrepancy between the left and the right side limit. Okay, so that we need to introduce a theorem. Okay, so where's my theorem here? So let me put this up. Okay, so this theorem saying that, okay, there we go. Okay. All right, let me move that up. Okay, so I'm gonna go ahead and just zoom in here. So the theorem say that, okay, for a two-side limit to exist, the limit from the left and the limit from the right must exist and be equal. Okay, that is, you have the limit from the left, the limit equal to L if only if. So this notation here stands for if and only if. Both left side and right side limit. So this is left-sided, and this is right side limit, equal to the same number. Okay, so if we go back to our example, if we don't have this scenario here where both and left side y values are approaching a similar number here, we don't have the limit exist at all. Right, this case here won't exist at all. Okay, so let's go ahead and go back to this. Let's introduce this definition here. So we'll say definition. Okay, left-sided limit. Okay, and right-sided limit. Okay, so notation-wise, okay, we have limit of the function f of x as x approaching some number c, some constant c. If we're looking at the left side limit, it's going to be approaching from the left side of c. Okay, and the right side is going to be the notation is going to be plus a superscript plus above the c. Okay, so what this theorem is saying that in order for the limit to exist as x approaches to this number c from both sides, both of these has to, so we said both left and right side limit must equal to the same number in order for the limit to exist as x approaches c. All right. So I'm gonna go ahead and pause on this video here, and I'll start the next video doing some more example, a little more visual examples, so that way it's easier to grasp the concept.